All right, we are here on in-class exercise lesson number 4, exercise number 7. And we're asked in this to find I2. So this is the quantity that we want to solve. And this is kind of a neat problem because we'll have to use both Kirchhoff's voltage law and Kirchhoff's current law. So this current here is labeled I1. This is I2. And even though I might say I20, since we got 1 and 2 here, we'll go ahead and call this I3. And I know this is capitalized, this is capitalized. I'll use lowercase i's to indicate current. Then also, we will have the sense of voltage. Now this is going to be from top to bottom because the current is entering the positive node, and we'll call this V20. If we can solve for I3, then we can get this voltage 20. And we've got the voltage here, so we're going to end up having a Kirchhoff's voltage law here at some point. But since we've got I2 coming this way, we can get the voltage across the 50 ohm resistor. So let's go ahead and call that V50. Now right now, we don't have a real clear path forward, but we're going to try to write some equations. And if we write enough equations, then we'll be able to eliminate the unknown variables. So the first thing that let's go ahead and write this I1. The I1 here is the same as the I1 through the current source. This is going to be I1. Now let's not worry about it. I know it's -2, and so that might cause some consternation. People might want to jump ahead and cross this voltage source out, flip it around so you can have a positive value. But no, we're just going to be working with equations, and if we plug in our numbers, we'll be fine. All right. Now note that we don't necessarily know what the voltage across this current source is, but we have it, the terminals themselves are connected across. So whatever V20 is also the voltage across this 2 amp source. And if we go around this loop, it doesn't really help us all that much if we apply Kirchhoff's voltage law, because we've got exactly what we'd know. If we went around here, we just know that these are the same voltage. The rise and the drop have to be the same. But we can write Kirchhoff's current law here. So let's give that a start. We can say that the current in is equal to the current out. So I2 is in, and we can say that is equal to the current out, which is I1 plus I3. And for right now, don't worry, I know that I1 is a negative number, but we're dealing with variables. Next, we can write Kirchhoff's voltage law for this 3-element path. It's not going to help us over here. So we'll go around here, and we can say then, we're going to sum the drops. So this is a rise, and this is a rise, and this is a drop. So we're going to have this V1. V1 is going to be positive. And then again, there's a negative sign here. So let's just write it as variables first, and then we'll worry about the numbers later. So we can say that negative V20 minus V50, these are both rises. We're going around clockwise. This is a rise, and that's a rise, and that's a drop. And then we can say plus V1 is equal to 0. All right, that's all true. We don't have to worry. We can plug some numbers in, which means now we don't know what V20 is yet, but we've got this variable I3. So we'll leave it like that for now, but then we can substitute something in. So V20 minus V50 plus a minus 6 is equal to 0. But we've got the currents. We can get some more auxiliary equations here. So when we move over, we can say, well, what's V20? V20 is equal to just I3 times 20 because of Ohm's law. We've got that. Then we've got V50 is equal to I2 times 50. I know we usually write the constant ahead of time, but all right. So what do we got? We've got I1. We know what I1 is. Yeah, it's a negative number, but we know what I1 is. So here we've got one equation, two unknowns. Here we've got some equations. Here we've got some equations. But if we start manipulating this algebraically, then let's see what we can do. Let's start eliminating voltages, and let's put these equations in terms of currents. So we have one equation, two unknowns here. If we can turn this all into currents, then we'll have a second equation for the two unknowns. Let's see what we can do. So V20, you can say minus I3 times 20, and then you can say minus I2 times 50. Then I'll go swing that over to the other side that we've got for 6. Okay, and now we've got this equation here. We know that that I1 is negative 2. So let's put that in terms, we can say that I2 is equal to I3 minus 2. Great, we're getting somewhere. And here we go. We've got two equations and two unknowns. So we can solve that. We can go ahead and put the I2 in here. So we've got minus I3 times 20 minus I3 minus 2 times 50 equals equals 0, equals 6. And let's check to see that we have all this. So we have minus V20 minus V50 plus V1, which is a 6. So we swing this over to the other side. Then we can factor our terms out. And so we get, then when we cook this down, we get 70 I3 is equal to 94 when you manipulate all of that together. So we get a minus 100 here, and we get the 70 I3 equals 94. Therefore, I3 is equal to 1.34. I2 is equal to I3 minus 2, which is then equal to negative 0.657. And move that out of frame a little bit. I didn't check that. And we've got then the answer to our problem.